Hello, my dear students. So let's discuss today solutions of Pathfinder book. Check your understanding section. Today we'll discuss chapter 8 thermal physics. I have made different videos of this chapter part wise so that I can give sufficient time to each and every question, right? So let's begin the discussion. So here is question number 1. You can pause your video here, try it by yourself, then we'll discuss it. Understanding language of question is also a task in physics, right? So try to understand language. I'm not going to explain this question. Okay. So give yourself at least 5 to 10 minutes. Okay. Now see the answer. So answer of this question is given. So delta T1 plus C1 plus C2 minus C2 by C3, then whole multiply by T2 minus T1. So it is not making sense. I have tried it multiple times. So the correct answer should be delta T1 plus C1 plus C2 minus C3 whole divided by C3 multiplied by T2 minus T1. So there is a small misprint in the book. Okay, so please correct it. Okay, now let's discuss the detailed solution of it. Okay, let's read first this question properly. A calorimeter contains a certain amount of liquid of heat capacity C1. So for a liquid, heat capacity is given C1, right? So means we can find out its internal energy. And a saucer contains a certain amount of salt of heat capacity C2, right? So means salt and liquid with specific heat C1 and C2. Heat capacity of the solution of the salt and the liquid is a C3. So like whatever keywords are there that we need to underline so that we can correlate the complete question. Where C1 plus C2 is less than C3. It is observed that if the salt is dissolved at temperature T1, temperature of the solution increases by delta T1. So what they are saying, if they are mixing liquid and salt, they are forming a solution, temperature of the solution is increasing, right? So now what can be the reason behind it? The reason is basically very simple. If you are adding any two substances, some reaction is going on, then there can be some energy released. If that energy release is consumed by the solution, then obviously its temperature can rise, right? So now that can be the reason. Okay. So now in the next line they are saying, knowing that the heat released while the salt is dissolving is independent of temperature. Okay, means if you are dissolving it at temperature T1 or temperature T2, whatever heat is released, that is the same. Okay, so that is a very important point because sometimes in some reaction heat release does depend on temperature. Here nothing like that. Find amount by which will the temperature of the solution change if the salt is dissolved at temperature T2. So if you are dissolving the salt at temperature T2, then what will be the rise in temperature, right? Now if you are doing brainstorming here, so it is clear that at a temperature T1, specific heat with the heat capacity, you can see initial internal energies are different, right? And if you are dissolving at temperature T2, then internal energies are different, right? So obviously now heat released is the same, so that's why change in temperature can be different. Okay, so that should be our approach, that heat of reaction is consumed by a solution due to which its temperature rises. So basically if I am writing reaction liquid plus salt is equal to solution plus heat released, right? So that heat released is say H. Now in case 1, when you are mixing it at temperature T1, then H is equal to final internal energy minus initial internal energy. right? So just like you write internal energy of any substance for gases, for liquids, solids. So similar here also I am writing internal energy of solute, that salt and liquid. So just like for gases, you write na F by 2 nRT. So this F by 2 R is basically CV. So NCV into T, you write internal energy like that only. If specific heat you know, then you can write internal energy. Or heat capacity is known, some is mass into specific heat is heat capacity. So that is internal energy initially, right? So for liquid as well as salt, right? And after mixing, their heat capacity changes. Now heat capacity became C3. Now suppose rise in temperature is delta T1, it means final temperature is the T1 plus delta T1, it means this is a final internal energy, so final minus initial. So that is what the heat release when you are mixing it at temperature T1. Now heat release is same, but these terms are different. So then obviously change in temperature can be different. So in the next step, if same thing I am doing, then heat release H I am writing C3 T2 plus delta T, right? So final internal energy minus initial internal energy. Mixing is happening at temperature T2. Okay, right. So heat of reaction is same in the two cases. It is given in the question only. So making these two things equal and rearranging, then I'm getting this solution. Okay. So that has to be the answer, correct answer. I have tried it multiple times. Okay. Right. Now let's move to the next question. Any doubt you are having in this explanation part, please write in the comment section. Okay. Now you see this question number 2. First, as I said, try to do by yourself. Pause your screen here. Understand language properly. Okay. Now answer of this question is this. 240 minute, A part and B never. Okay. So let's see what is actually the question, the language of the question, right? A vessel contains 20 liter of water at temperature 20 degrees Celsius, right? When a heater inside the container which can supply heat at a constant rate is switched on, means some heater is there which is switched on, the water temperature reached a value 60 degrees Celsius. Means with the help of this heater, temperature is changing from 20 to 60 within a time interval of 40 minutes, right? So means for 20 liter water, temperature is increasing from 20 to 60 in 40 minutes, right beta? It means indirectly what they are indicating, power of the heater. Now water of temperature 20 degrees Celsius is slowly added into the vessel at a constant rate of 200 centimeter cube per minute, means 0.2 liter per minute, right? So after the liquid has reached to a temperature 60 degrees Celsius, now in every 1 minute you are adding 0.2 liter of water. Heat capacity of the vessel and heat loss to the surroundings are negligible. Okay, right? So no heat loss to any other thing. So whatever heat is coming from heater, it is directly consumed by water, right? That is they are giving. How long after the beginning of experiment will water starts boiling, right? So you already had 20 liter water and in every 1 minute you are adding 0.2 liter water, right? So what should be the approach? You can apply heat conservation, right? From initial state to final state, right? And with the heater supplying constant energy per unit time. Okay, so that should be the approach of first part. And in B part they are saying instead of water some other liquid having all properties same as that of water, means specific heat, everything except the boiling point which is 150 degrees Celsius. How long after the beginning of experiment will the mixture starts boiling, right? So now same thing you are repeating, but with a liquid having boiling point 150 degrees Celsius, means after After what time the mixture will reach a temperature of 150 degrees Celsius? So that is the question, second part. So now the approach, as I said, it is very much clear that conservation of heat. So first part of the question will give power of the heater, right? As I said, first statement, and next part will give required time, right? Now if P is a power of heater, then P into 40, because in first 40 minutes they are saying, na? So 40 minutes it is happening. Temperature is changing from 20 to 60. So 20 liter. So I'm keeping the units as it is, into rho. So mass of the liquid, into C into delta T. So from here they are indicating value of power, right? So 20 rho C. The units I am not changing because it will get cancelled out. Okay. Now 0.2 liter of water you are adding in 1 minute. It means suppose boiling will start after t minutes, right? If suppose boiling is starting after t minutes, it means how much extra volume you have added in t minutes? 0.2 into t. Okay, so this much volume you have added, but that power supply is the same, right? So if t is time when boiling starts, from the instant water is added, when you are adding water na, from that point you are writing this t. So p into t is equal to what water you have added so far, 0.2 into t into again density, specific heat. So change in temperature is 100 minus 20, because at the time when you are adding water, the temperature is 20 and final temperature should be 100. And what liquid was there already, right? It was, right, this only having temperature 60. So the liquid which was already present in the container, that had temperature 60. So mc into delta t you are doing. Okay, so then solving this equation, you are getting t is equal to 200 minutes, right? So total time from the beginning of experiment, actually that is required. So already 40 minutes over. Now after that, how much time further required? 200 minutes. So it means total time should be 240 minutes. So that is our answer. Okay, beta. Now B part. Now what I will do, again I will try to write similar equation as I am writing here. We are finding temperature is 100. What I will do, I will try to write same equation with this, in place of 100 I will write 150. So if like that I am doing, I am getting temperature negative. So what does it actually means, right? So what is the meaning, physical meaning of this? Means after some time, when a particular temperature is reached, after that heat required to further raise the temperature, right, is more than how much heat is supplied by the heater. Okay, because water you are continuously adding at same 20 degrees Celsius temperature only, heat supplied by the heater is constant, right? So it is possible that after some temperature, what will happen, heat requirement exceeds what heat you are supplying. Okay, so that's why we are getting temperature negative. So it means it is not possible. And in this hint section they are writing that maximum possible temperature is 120. Okay, so that maximum temperature is 120 only, right? So by this process, okay, so means if this final temperature you are writing it as a variable, right? So in place of 150 you are just writing capital T, right? So on rearranging, what you will get, the maximum value of that will be 120. Okay, right. Now let's move to the next question. So that is next question. Try to understand language of the problem. Pause the video. Okay, now let's discuss. So answer is this, right? That is the answer, which is 100% correct, no problem. Value wise, okay. So narrow or other container. So two containers are there. So let's see that what is the language of question. So first what I will do, I will mark the keywords. That is the way how to do JEE advanced questions. Water of equal mass M. So first of all, equal mass is filled in each of the two cylindrical containers and then cooled to freeze into ice at 0 degrees Celsius. Right? So equal mass M, which is ice at 0 degree Celsius basically. Area of base of one of the container is A and that of the other is 2A. Means area of cross section of the containers are different. Both have what? Ice. Which vessel must be supplied greater amount of heat to melt whole ice in it, right? So you need to supply heat. Now for heat we know the formula is m into L. So mass is equal in the two containers, right? So the mass is equal. So then why heat requirement will be different, right? So find the difference of heat supplied to both the vessels. Heat capacity of the vessel and loss of heat to the surrounding are negligible, right? So here also vessel is not absorbing any heat and heat loss, that is also zero to the surroundings. Denote by suitable symbols all the physical characteristics of water or ice you need, right? Now here if you are doing brainstorming, then you can realize that when ice is melted into water, what will happen? Its volume will decrease, right? So its volume will decrease. It means what? Its height, means its height also will decrease. It means center of mass is going down after melting. So center of mass is going down after melting. It means gravitational force is also doing work, right? So since gravitational force is also doing work, right? So it means energy supplied by you, that is slightly lesser than how much energy is required actually, right? So m into L thing. So from this m into L thing, how much less energy is required, the whatever is the amount of work done by gravity. So that should be the approach. So what we need to calculate here. So what is initial and final potential energy or work done by gravity in this melting process? That is what we need to do here. So that is the approach of the question, right? So densities of ice is less than density of water, right? We know. So during melting process there will be work done by gravity. Okay. Okay. So now in container 1, say area is A, container area 2A, right? So what I am doing, I am calculating height of ice before melting. So mass they are saying the same. So m upon density, volume upon area cross section, height, right? So second container also mass upon density is volume upon 2a, area of cross section, that is height. So height of ice. Okay, after melting, again same formula I am applying. Density is density of water, right? Okay, so work done by gravity. So for either of this container, work done by gravity is mg into change in height of center of mass. So center of mass is what? At the midpoint. So height of ice by 2 minus height of water by 2. Okay. So that is work done by gravity in the two cases, right? So using this formula, what I am getting here, work done by gravity in container A, work done by gravity in container 2. So work this to melt, heat requirement m into L, that is same. Okay. So actual heat requirement, the difference will come just because of difference in work done by gravity. So if you are subtracting them, so what you are getting, beta? This answer you are getting. Okay. So work done by gravity in case first case, when area cross section A is more, right? It means for it heat requirement is less. So heat should be supplied in a narrow container. So less heat should be supplied in the narrow container. Okay, that should be the right answer. Okay. Now question number 4. Okay, so question number 4, very good question, right? So see this question properly. Any confusion is there, then tell me, write in the comment section. Okay, the answer of this question is correct only, no problem. So that is the answer. So basically in hint they are giving how to solve this question, and the hint is also 100% correct, no problem in that. So here let's see what they are saying in the question. A recently designed heater makes use of latent heat obtained in freezing a liquid. So means when a liquid is freezing, so what is happening? When a liquid is freezing, then it will release heat. Okay, so that heat they are going to use latent heat of obtained in freezing of liquid, which is done by adding a suitable catalyst. Means to convert it into liquid to solid, some catalyst you are using. This freezing process is possible over a wide temperature range. Means this property is different from water. Means that freezing can happen at any temperature, they are saying. The heater shown in the figure is a box, right? That is a right heater. Dimensions are given. Made of an insulating material containing a liquid having the above mentioned property as a working substance. The catalyst is added from left and in much a controlled manner that the frozen portion grows towards the right at a slow and steady rate V. Okay. It means in any small interval we can find out that how much volume of liquid is freezing from this data. Find an expression for temperature theta of the heater as a function of time. Okay. So we need temperature of this whole thing in any time at any time t, right? So specific latent heat of fusion of liquid is L. Specific heat of the working substance in liquid state is S. In solid state 10% less. Means in liquid state if it is S, then in solid state it is 0.9 into S, like that. Initial temperature is 0 degrees Celsius. In liquid as well as in solid state, working substance has same density. Okay, density is same. And very high thermal conductivity. So very high thermal conductivity means what? So the moment it is freezing, right? So then to conduct it is not taking much time. Means that heat conduction rate is very fast. Okay. So you can just assume that immediately heat will be absorbed by the complete liquid and solid part of the heater. Okay. Neglect heat capacity of the box, heat loss to the surrounding. Okay. Now, what should be the approach? The energy released in freezing is absorbed by a material which will increase its temperature, right? Obviously. So, as I said, they are giving a velocity. So, at any instant, suppose x length is already freezed, right? Now, velocity they are saying it is uniform, right? So, where the freezing is happening. So, in any time dt, so v dt, so this length dx, right? So, this much is becoming what? Solid, right? So heat released for this portion is dm into L. Okay, so this heat will be taken up by solid portion and some heat will be taken by liquid portion. Okay, so mx into 0.9 s, because specific heat of solid is less, 0.9 into s into dt, and for liquid portion ml minus x into s into dt, right? Okay, so now mass you can write area of cross section into dx. So since area of cross section is given in the problem but actually not required, right? It's cancelling out from both sides. So a into x 0.9, a into L minus x into s dt, right? So like this, this equation I am getting. So x I can write v into t as v is constant. So at any instant length of solid portion is v into t, right? And then integrating, so we are getting the answer. Okay, so theta is theta naught. So this equation I am getting, which is the answer given. Okay, right. Now let's move to the next question. And so in next question, if you see, actually very good question, right? A lead pellet is embedded in an ice ball. So we have a lead pellet in a ice ball, right? Okay, sorry, first you read this question, try it by yourself, try to understand this language also by yourself, right? Okay, so after getting answer, means after trying only I can explain it. So try this. So answer given is this, some big expression, and this is the final answer. Okay, so match if it is matching with your answer. Okay, now let's read the question properly, what they are asking. A lead pellet is embedded in an ice ball, right? So ice ball, and inside it we have a lead pellet. Mass of ice in the ball is 0.9 kg, right? So ice is what? How much? 0.9 kg, and its temperature is minus 42 degrees Celsius. So temperature is minus 42 degrees Celsius. when the ice ball is gently released on the surface of water kept at 0 degrees Celsius. So here you can notice that temperature of water is 0 degrees Celsius, right? So it means this is solid, this cannot melt, right? This ice ball cannot melt because it cannot take any heat from water. It is already at 0 degrees Celsius in a large container. It first sinks to the bottom, right? And then after some time it comes out. So first it will sink and then after some time it will come out, right? So what can be the change here after sinking? So you can notice here temperature is minus 42 degrees Celsius. So temperature is what? Very less. It means the liquid layer around ice ball can freeze. Means volume of this ice ball can increase, right? Okay. So now floats partially submerged in water, find the range of mass m of the lead pellet, and these values are giving density, specific heat or whatever. Okay. Now but here from this language only we should understand, they are saying what can be mass of a lead pellet, and very important information is heat capacity of lead pellet is negligibly small. It means the amount of heat absorbed by lead pellet is very less, right? Okay, now let's do it. Now first the approach, as I can see from the question, it should be what, beta? So initially it sinks, means initially gravitational force should be greater than buoyant force, right? And when it sinks, because of its very less temperature, what it is doing, it is absorbing heat from outside water, right? It's absorbing heat from outside water. So it means outer water is already at 0 degrees Celsius. It will freeze into liquid. So when it is freezing into liquid, what is happening? Volume of the ball is increasing. Means after some time, since volume is increasing, buoyant force should be more than gravitational force, right? So mass of lead pellet should be such that finally buoyant force should be more than gravitational force till its temperature loss is from minus 42 and final temperature 0. Till that temperature change, buoyant force should exceed what, beta? Weight. So that should be the approach. Initial weight of ice ball should be greater than buoyant force so that it can sink, right? And finally, after heat absorption, it should be less than buoyant force so that it can float. So that is the basic approach of the question. So initially gravitational force should be more than buoyant force. So mass of ice is there, mass of pellet is a small m. So gravitational force you can write like this, right? Mg should be greater than buoyant force. So volume corresponding to ice material, volume corresponding to pellet. So nowhere it is written that pellet is very small. No, that is not written anywhere. So that's why I am considering volume of lead pellet also. So m by density of pellet into, now this is total volume immersed, density of water into g. So this should be greater than this. Okay. Now I'm rearranging the term, solving. So then what I'm getting, m should be greater than this expression. So now you're substituting these values, density of period, density of water, density of ice. What you're getting, mass should be greater than 110 gram. Okay. Now in the second stage, when we are saying that finally it is floating, so then what should happen? As I said, buoyant force should be more than gravitational force. So after absorbing heat from water, mass of ice ball increases by m dash. So that is the crux point of this question, that the mass of solid ball is increasing. So how much it will increase, that also we can write very easily, right? So this ice ball, that is how much heat it is absorbing from liquid, mc into delta t divided by latent heat of fusion. So you can say that is increase in mass of ice ball, right? So that is m dash. Okay. So now in the expression, so now everything is same, right? So in place of 0.9 kg, I can think total mass of ice is 0.9 plus m dash, and gravitational force should be less than buoyant force. Means exactly this equation, exactly this thing, sign will be different. This sign is just opposite, and mass of ice 0.9, it is not 0.9 plus 0. 0.9 plus m dash. So wherever 0.9 is coming, finally you can write 0.9 plus m dash, and this sign you can just change it, right? So then you should get this, right? Or if you want to write separate equations again, then also no problem, same answer will come. So m should be less than 0.9 plus m dash into the same expression. Okay, solving it, what you are getting? 143 gram. So it means mass should lie in this range, right? Okay, so very good question. Any doubt is there, or you have any other solution, please write in the comment section, no problem. Okay, question number 6. So question number 6, beta, let me tell you, according to me it is a wrong question, right? Because I have tried multiple times this question, so I think this question is wrong, right? So please do not try this question, or even if you want to try, yes, you can try it. Maybe you will come up with a better idea, right? Then your answer is matching. In that case, please send me the solution, okay? Or write on the comment section that, sir, what you are explaining is not correct, and that should be the right procedure, okay? That you can tell, no problem, right? Okay, so directly you can see the solution part, so what I did in this question, right? So hint also they are writing, na? From this hint only we can understand what is the property of wood, dry and wet wood. Okay. So in a cold but freezing weather at temperature 0 degrees Celsius, it is required to burn 34.1 kg of dry wood of density 600 to heat up a large room, right? So to heat up 34.1 kg of dry wood is required. Now you are simply supplied with the wet wood. So we have now wet wood which density is 800 and asked to heat another identical room under identical condition. How much wet wood will you have to burn to accomplish this task? Smoke produced in burning the wood is taken out of the room through a chimney. Okay, calorific value of dry wood is given. Right, so amount of heat released on burning per kg. So that is given. It means initially with dry wood, how much heat you are giving? This mass of wood multiplied by this. So this heat you are giving to the room. In case of wet wood, so what we have? Water inside the wood. So not only you have to supply heat for the room, you have to supply heat for what, beta? For changing this liquid into gas, right? So this water you need to convert into gas, right? That also heat required, right? Okay, because if it is boiling, after boiling, after evaporating only, it can leave the wood surface, right? Okay, so we have to calculate. Now approach is very simple. We have to calculate mass of the dry wood for wet wood density, which is responsible for heating. Means what I am trying to calculate, beta, here first, that if you are taking any mass of wet wood, out of this how much is the fraction of dry wood present and how much fraction is the water present. So that is what I am trying to do here, right? So mass of dry wood plus mass of water divided by volume, right? So now wood properties, as we know, water will enter only in the pore spaces. Okay, so whatever volume is there for dry wood, almost the same volume will be there for wet wood also, right? So density of wet wood is given. So in that I am saying m dry. So that is mass of dry wood present plus mass of water present. So that I am doing, and the mass of water I can write total mass of the wood minus mass of dry wood, and volume being same, right? So this I am just rearranging the terms. I am getting mass of dry wood as total mass multiplied by density of dry wood upon density of wet wood. So this I am getting. So I am getting an expression like this. So mass of dry wood is 3 by 4 times mass of total, right? Similarly, water inside, mass of water is 1 by 4th of mass of total. Means 25% in this wood water is present, and 75% is the dry wood, which is responsible for heat release, right? So which is responsible for heat release. Okay, right? Heat given to the first room by dry wood, that is there. Okay, so as I said, so in the next case, how much heat we need to supply? So not only to give the required heat in what heat was required by the room, not only that, but to change water into gases and to raise its temperature to 100 degrees Celsius. Now I am writing this equation. Okay, so I am writing this equation and I am finding it that this quantity is more than this. Okay, that is my problem. It means heat required for water molecules present in the wood to evaporate, that is basically more than how much heat we can extract from dry wood. So this thing is coming more than this. So it means whatever mass is there, you cannot supply any amount of heat. So means this H, this extra H you cannot get. Or if I am simply solving it, I am getting M negative, right? So that's why according to me this question is not correct. Okay. Okay. So now try the next question. Question number 7. A kettle of negligible heat. Okay, please read by yourself. Try this question. Pause your video here. Okay. Now correct answer of this question is 0.1 kg and it is given in the book also, same answer. Okay, so now let's discuss this in detail. A kettle of negligible heat capacity contains 1 kg of cold water at 0 degrees Celsius, right? So 1 kg of cold water at 0 degrees Celsius is put on a massive plate of electric heater, right? So there is an electrical heater and a plate. So heater has a plate, massive plate of constant power. Okay, so electric heater has constant power. Water starts boiling in 15 minutes, right? So since it has a plate also, so when heater is supplying heat, then some heat will be absorbed by its plate and remaining heat will be absorbed by water. Okay, if another 1 kg of cold water is added into the kettle, the whole water starts boiling after an interval of 10 minutes. Now you see this, next time when you are adding more water with same condition, then boiling is taking place in less time. The reason being is the heater plate now is not absorbing that heat. Initially, assume it at 0 degrees Celsius or whatever temperature of initial temperature is there of heat plate, sorry. So now it is not absorbing any heat once it has reached the boiling temperature. Okay, so that's why time taken in the second case is less. Now the heater is switched off. If entire heat stored in the heater is transferred to the water, calculate mass of water evaporated after the heater is switched off. Okay. So obviously in the first step we need to find out how much heat is stored in the heater, and then finally that heat we need to give to the total liquid present in the container. Okay. Heat stored in the heater plate can be related to time taken in both steps of heating. Right. So in the both steps of heating, we can find out how much heat is stored in the plate. Okay. So now if P is power of heater and C is its heat capacity. So heat capacity means heat capacity of plate. Right. So then I can write heat supplied P into T1 is equal to heat H. H to raise temperature of the liquid from 0 to 100. So this is H. Okay. Plus heat absorbed by plate. So I am writing it as C into 100. So heat capacity multiplied by change in temperature, assuming initial temperature 0, right? But if you just assume it is some X, then also same answer, right? So it's not like this as because of this assumption only we are getting answer. I'm just writing it as that suppose it is at initial temperature, final is 100, and that is heat absorbed by plate. But you can just write it as X, no problem. Okay, this will not change our solution. Our time taken is 15 minutes. This T1 is 15 minutes in the first case. Now in the second case, as I said already, heater plate is at its maximum temperature, right? So whatever heat you are giving in the next state, it will be taken up by water. Now that water you are adding, its initial and final condition are same as in the first step. So P into T2 in the next time, whatever heat is supplied by the heater directly going to the water, right? And how much heat? Same heat. Okay, beta. So that is equation number 2. T2 is 10 minutes. So if you are solving these two equations, so what you are getting, this 100C means what I said, some X, so heat taken up by heater plate, so that you are getting as an expression. So this value you are getting, right? Now already water is at boiling point, so whatever heater plate carrying heat, that will be given to the water. Okay, so for its vaporization, so this M is required. So using this, right, M is 100C by latent heat of fusion, or some X divided by latent heat of vaporization. So substituting the value, I am getting 0.1 kg, right? So generally you might have seen heaters also. So heater, after reaching a particular temperature, then slowly its temperature decreases, means still that is in a state of releasing heat. So basically that heat you are releasing. Okay, so in a heater it is heating plate. So when you switch off the heater, it's not like immediately heat is stopped from coming out of the heater. So because heater plate is at a certain temperature, the heat is continuously coming out from the heater, right? So now that heat also we are using in the problem. Okay, now next question, question number 8, right? So read this question beta, so we'll discuss it. Good question. Okay, so answer given is 55 degrees Celsius, which is 100% correct. No problem. Okay, so now let's read this question. An ice piece at temperature 0 degrees Celsius is affixed at the bottom of an insulator, means bottom and affixed, means ice piece is there, but it's not like it can come to the surface, it is fixed at the bottom. Insulated cylindrical vessel, means again there would be no heat loss to the surrounding and this, right? Water equal to that of ice, water equal to that of ice, right? So means mass of ice and water are equal, right? Gently poured in the vessel. Area of base of the vessel is small enough so that water completely covers the ice piece and reaches a level 19 centimeter above the base. Okay, it means what they are indirectly giving, total volume of water and ice they are giving. Suppose capital A is area cross section, then capital A into 19 is total volume, right beta? Initially water level starts coming down and finally settles at delta H is equal to 0.7 centimeter. So initially water level starts coming down and finally settles at level delta H 0.7 centimeter below the initial level. Find temperature theta of the water before it was poured into the vessel. So what we need, beta? Temperature of the water before it was poured into the vessel. So what is happening here? See, so water starts coming down. So why water will come down? Why this volume is decreasing? The obvious reason is in the form of ice. Water has less density, means more volume. So when it is melting into water, right? So what is happening? Its volume is decreasing. Okay. So this question can be done by volume conservation. Okay. So what is the initial volume? What is the final volume? And how much ice will melt? That we can find out with the given condition, right? So the initial temperature of liquid is required because of its temperature is more than 0 degrees Celsius. Because of that only ice is melting. Okay, so that is the concept of this question. So based on volume conservation, so decrease in volume of system is equal to decrease in volume of ice due to melting. So that is the concept behind this question, the approach part. Okay, so now initial volume of the system is A into 19, so that I can write. So as they said, masses are equal. So mass of ice divided by density of ice plus mass of water divided by density of water. Initial mass of ice and water are same. Okay, so that is first step. Now change in volume of the system is A into 0.7. So this volume means what? Suppose m dash mass is melted. Suppose m dash is the mass of ice melted. Then when it was in the form of ice, its volume is this. Now when it is in the form of water, its volume is this. So its change. Its change should be equal to the change what they are giving. Okay, so that is our next step, which is the crux point of this question. Okay, right. Now if you divide this equation 1 by 2, so what we are getting, m dash. So mass of melted ice you are getting in terms of mass, that equal mass is m they are giving, right? And how much it will melt, it will depend on initial temperature of liquid. So m into specific heat of water T, final temperature has to be 0, because final temperature is not 0, then it will keep on melting. So final temperature of liquid is 0. So then that is what heat released by the water, and that is heat absorbed by ice in melting, right? So we are getting it in terms of m dash and m dash by m already we got as an expression. So if you substitute it, so then we are getting this equation, and using the values given, we can find out the final temperature as 55 degree Celsius. Okay, beta. Right. Now let's move to the next question. Okay. So next question I think is a bit easy. So read this question first, then we'll discuss. Okay. So answer given is 30 degrees Celsius. Perfectly fine, no problem. Okay. So a block of mass 100 gram, temperature is 0 degrees Celsius, immersed in a calorimetry containing 500 gram of water at temperature 45 degrees Celsius. So we have a block, right, at 0 degrees Celsius placed in what, 500 gram of water at temperature 45. Now specific heat of the material of the block depends on temperature theta according to the equation. This means specific heat is given by an equation. It means it's a rise in temperature. You cannot just write initial and a final temperature. You have to integrate to find out how much heat will be absorbed by the block, right? So you have to integrate it. Okay. And then heat released by water, simply you can write by m as delta T. So as I said, it's an easy question only. Specific heat of block is a function of temperature. We cannot directly write initial and final state. Okay. So heat absorbed by block. So dq is m specific heat as a function theta, and d theta change in its temperature. Okay. So total heat when its temperature is changing from 0 to theta, so I'm getting in terms of theta like this. And heat released by water is what, this 500 specific heat of water, change in temperature 45 minus theta. So making these two things equal, so we are kind of getting an equation, right, which is very easy to solve. So this equation we are getting, so we are getting theta as 30 degree Celsius. Okay beta, that is the answer. Okay. Now next question. Okay, so from next question I will form a separate video and upload as soon as possible. Okay. Have a good time. Okay, thank you students.